All right, so I was just flipping through some of the quizzes you guys turned in. It wasn't looking that great, but I think a lot of you guys already know that. I do drop the lowest quiz grade, and we'll just see how things go, okay? So after this week, so I'll try to get those quizzes graded, and by next Tuesday I'll have sent out a grade report, okay? It'll have, so listen up you guys. So I'm going to send out a grade report, and that grade report is going to have everything that you've turned in and your grade calculated up until this point, okay? It's Tiffany, you're actually going to be able to turn in there again. So it will, and it will already drop the lowest quiz grade, okay? And it will calculate what you need to get on the final. Okay, the grades are calculated with the assumption that you will turn in next week's homework assignment on time. Okay, so I'm going to automatically factor in 10 points for next week's homework assignment into your grade, and that will go through. Okay. Now, if you don't turn in your homework assignment on time next week, then all of those grades will be higher than what they actually are. Does that make sense? Because I'm assuming you guys are going to turn in the homework in on time, but if you don't, you're going to lose points, and that's going to make your grade lower than what it actually is. But okay, but it will have your 3 highest grades, and it'll tell you exactly what you need to get on the final to get what you want. Yes?
Will you also factor in the credit points?
Yeah, I'll put in the extra credit points and all of that stuff, okay? So it'll basically be everything except for the final, with the assumption that you turn in.
Yeah.
Yes, it'll say if you want an A, you need this. If you want an A minus, you need this. If you want a B plus, you need this. All the way down to a C, okay?
Is it a B plus, B minus, B a grading system, or just A, B, C?
There's pluses and minuses, okay? When it transfers over to your school, the school that you are transferring grades to, they will decide whether to factor in the plus or the minus, okay?
Oh, okay.
Every school that receives grades has a different policy. So I do plus and minus. The schools that you receive, they may or may not, okay? Passing, if you want a C, or if you're taking this pass, no pass, if you want a P, you need a 70%, 70.0, okay? So, and that's a hard line. So if you get like a 68%, that's not a C, okay? That's going to be a D, all right? So that's how it's going to go. Okay? Are there questions on that? All right. This quiz is probably I don't know if you guys took a look at the practice final exam, but this quiz is probably the closest thing that the final exam is going to look like. Okay? For some of you, that's good. Others of you, that means you've got 2 weeks to study hard and prepare yourself for the final, okay? I know it's tough. The final exam is all multiple choice. That is correct. Okay. All right. Yes. Yeah. The final exam is all multiple choice, and that's just to help me get the grades out quickly. Okay. Yes. Question. Yeah, the final exam is going to be very heavily chapters 8 and 9, okay? Because chapters 8 and 9 is everything, you know, all of chapters 1 through 7 have been building up to chapters 8 and 9. So if you can do chapters 8 and 9, I know you can do chapters 1 through 7, okay? That's why the final exam is going to look a lot like chapters 8 and 9. It's not that those 2 chapters are more important, it's just that captures all of the stuff from before. Okay. Yes.
On the practice exam, it seems like all of it's like written, like we do on our quizzes.
Yes.
So how will that translate?
Okay, so the practice final seems like it's short answer. On the final exam, it's multiple choice, so the questions will be the same way, except you'll have 4 numbers to choose from, okay? Obviously, when you do your calculations, you're hoping your calculations will line up with one of my answer choices almost exactly. If it doesn't line up exactly, I would say pick the closest one, okay? In the answer choices, one of the answers is correct, okay? I do all of my calculations as if you did no rounding, all right? So if you take the whole 8-digit number in your calculator and you use that in your further calculations, et cetera, okay? All of the answers that I calculate are based off of that. So one of those answer choices are correct. If you made a mistake in your rounding, probably your answer will be slightly off, slightly different from one of my answers. If it's just off by a little bit, I would just say pick that number as your answer, okay? If your answer is very different from any of the answer choices selected, then you probably did something wrong, okay? So I think that's, it's worked out, and I believe it's fair. In the past, students who've done well throughout the quarter did well on the final exam. Students who did not do well throughout the quarter did not do that well on the final exam. It matches, the grades on the final match pretty closely with what I would have expected from those students, okay?
When are we getting our grade reports?
You'll get them by next Tuesday, okay? So give me the weekend to get all of the grading done. Go, okay? All right, is that okay? So this week, we're covering a little bit of new stuff with Chapter 12 and some concepts of Type 1 and Type 2 errors. We're going to cover that stuff. It's pretty lightweight stuff. It's more so definitions. And then we'll start to review some of the concepts from Chapters 8 and 9, which are important. And this week, your homework assignment is very easy, okay? There's just a few questions. You just do that, you turn it in. Next week, you'll get 10 points, okay? But the other part of your homework assignment, which is more important, but I'm not collecting, is that you print out the practice final exam, which is available on the website, and you work through that, okay? On the website, there's a page that says about the final. I want you to, and on that, there's a practice final exam and a study guide, okay, or just kind of a guide that gets you through doing these problems. I want you to work through the practice final, okay? Try to do all of it during the week, and that way when we do our review next week, it will you'll have the you'll know what's going on, okay? If you because next week during our review session, we're going to work through the entire practice final, and I'm going to explain everything along the way and answer all of your questions. And if you've done the practice final before then, the review session will be a lot more meaningful and valuable to you. If you don't do it, you're going to be under the false impression that you understand everything, because when I work through problems, everything makes sense. But when you try out the practice final this week, on your own, you're going to realize where you have gaps in your knowledge. Okay, kind of like on today's quiz, which looks very similar to the final exam. You'll know, oh, wait a second, I'm not so sure about this or that. Okay, yes.
Well, I didn't look at the practice final yet. So, is it 50-question practice final, or
the practice final is over 50 questions.
So it's like pretty much the same format as the final.
How long do we have?
Yes. Okay. I'm sorry?
How long do we have?
For the final or for the...
For the final.
For the final, it's a 3-hour exam, okay? I mean, you have 3 hours. It'll probably take you 2 hours, okay? Some of you, most people should be done within 2 hours. Some people, they'll sit there and just stare at a problem until the very end, hoping something comes to them. But yes, question?
How many questions is going to be?
The final exam is 50 questions long, okay?
And are they like formatted like for quiz? Or like separated?
Yeah, it's kind of like, so the final exam will be similar in that in today's quiz, I had kind of a scenario described, and then I asked questions like, what are the hypotheses? What's the standard error? What's your test statistic? And what's your p-value, et cetera, et cetera, et cetera, okay? The final exam is going to be similar. I'll have a scenario described with data, and then I'm going to ask, what's the hypotheses? Or if it's a confidence interval, I'm going to say, you know, what goes in the center of the confidence interval? What's your margin of error? What's your critical value? Things like that, okay? So it breaks it out. It shouldn't take 3 hours to do, okay? Again, the practice final is 50 questions long. 40 questions will look very similar to questions from chapters 8 and 9, okay? 40 questions will be similar to chapters 8 and 9. The last 10 questions will be miscellaneous stuff from throughout the quarter, either definitions or concepts from before the midterm, or just a few other random things, okay? I think it's a very fair test, okay? Anything else? Okay. Yes.
What about the homework you're going to give us for chapter 12? It's not on the test?
Yeah, there's 4 questions from that, okay? 4 questions. Okay, yeah, so I maybe it's more like 35 questions that are from chapters 8 and 9, and then 4 or 5 questions from other stuff, okay? I think it's a fair test, okay? The practice final is longer than 50 questions, but we'll work through the whole thing with me explaining every step along the way within 3 hours, so it's okay. All right, is that okay? We'll go. Any no other questions? All right. Okay. So let's cover a few concepts. Okay. So this is just a few more things on hypotheses tests that you will need to know. Okay. So this is errors, inherent. 2 R's? I don't know. Just 1 R. Okay. Inherent to okay. So these are errors inherent to hypothesis testing. So when we talk about errors in hypothesis testing, I'm not talking about you making a mistake in your work and getting the wrong answer. Okay? This is you've done everything correctly, but there's still just the chance at the end that your decision was the wrong decision. Okay? Because remember, in a hypothesis test, we have a null hypothesis and we have an alternative hypothesis. Okay? So let's say our problem, or the scenario, reads something like this. Okay? We collected some data.
No?
To see if there is a change in prices. Okay? We'll say last week we visited 30 randomly chosen gas stations. In LA. And the average price was, I don't know, 402, 4029, with a standard deviation this week, we went to another 25 random gas stations in LA. Okay, average price for regular is 4089 with standard deviation of 0.07. Alright, and we'll ask, is there evidence of a change in gas prices? Okay. Is that okay? So am I dealing with means or proportions? Means, yes, okay, I'm dealing with means. And do I have one sample or two samples? Two samples, okay, so I've got two sample means. Okay, so far so good? Okay, so then, if I got two sample means, what is my null hypothesis? Yeah, mu1 equals mu2, or mu1 minus mu2 equals 0. Is that okay? And this, so this is what it is symbolically. In English, what does this mean? Yeah, or, okay, either instead of saying mu, we want to say what? Average gas price. Okay, average gas price between last week and this week hasn't changed. Okay, so there's no change in average gas price. That's the null hypothesis. There's no change in average gas price. Is that okay? Alright, so what's my alternative hypothesis? Because I'm asking, is there evidence of a change?
It doesn't equal like this last.
Yeah, so I do mu1 minus mu2, okay? And then I use the same number, and I'm going to use doesn't equal, right? Not greater than, not less than, but I'm using not equal to. Why? Because it says change, right? So this doesn't imply direction greater than or less than. It just says not equal to. Alright, is that okay also? Alright, so anyway, we can go through this problem, and what's going to happen if we go through the problem? Okay, without doing any calculations, two things will happen, right? I go and I find my standard error, okay? So the steps here, so now that I've got my hypotheses, what do I do next? I figure out my test statistic, okay? Yeah, and the test statistic is determined by finding the observed difference. Minus 0, and then we also require us to find the standard error, right? So once we figure that out, we get our test statistic. After we get our test statistic, what do? Yeah, we look this up in the table to get a p-value. Okay, and after we look that up and get a p-value, what do? Not the hypothesis, we compare it to alpha, right?
Oh,
Yeah, compare p-value to alpha. our conclusion. I'm hoping this is okay with everyone, or does it feel very foreign? I know some of you struggled on this quiz, so we'll work through this several times, and I'm hoping this will become good. Okay, so anyway, we compare our p-value to alpha and make our conclusion. What are the two possibilities? There's only two things that could happen when we compare our p-value to alpha.
It could either be smaller than 0.05 or greater.
Okay,
Or-
it's
or
either
it could-
smaller than our alpha
Yeah.
or bigger than our alpha. There's only two possibilities. So during the compare phase, there's only two possibilities. Okay? The first is our p-value is less than alpha. If our p-value is less than alpha, okay, let me just list these up. So the first one is our p-value is less than alpha, or what's the other possibility?
Greater.
Our p-value is greater than alpha. That's it. Greater than or equal to. Okay, if the p-value is less than alpha, what do? We reject. What do we reject?
Null.
We reject the null hypothesis. And we say we have evidence that what?
That
there's a change in gas prices.
Okay, well, the most basic general sense is we have evidence that the null hypothesis is false. Okay? Whatever the null hypothesis says, we have evidence that H0, the null hypothesis, is false. Okay? And up there, the null hypothesis was that there was no change in average gas price. So if that's false, what does that mean?
There is change.
There is evidence of a change in gas price. Okay? We have evidence that there is change in gas price, average gas prices. That's if we reject the null hypothesis. Is that okay? On the other hand, if the p-value is greater than alpha, what do? We do not reject the null hypothesis. And then what do we say? We do not have evidence Okay. Notice I write we do not have evidence that the null is false. I never write we have evidence that the null is true. Okay, I never write that. Alright. So let's say we go through the problem and either this is going to happen or this is going to happen. Okay? Let's say we go through the problem and this has happened. The p-value is less than alpha. Then that means, so I go through, I calculate it out, my p-value is less than alpha, and so that means we reject the null hypothesis and we have evidence that the null is false. Or we have evidence that there is a change in gas prices. Okay? So in our example, let's say our p-value equals 0.01, alright? And alpha is 0.05. In this case, the p-value is less than alpha. We reject the null hypothesis, and we say we have evidence that there is a change in gas prices. possible that there's actually no change in gas prices? I've gone through, I took my data, I looked at 30 gas stations last week, and I looked at 25 randomly chosen gas stations this week. And according to my data, I have concluded that I have evidence that there's a change in gas prices. Is it possible that there was no actual change in gas prices?
Yes.
Okay. How is that possible? I went out and my data says, okay, and I've done the math. Let's say I did the math correctly, and my data shows clearly that there is a change in gas prices. But you're saying it's possible that there's no change in gas prices. How is that possible?
Because we don't have enough evidence, like, we don't.
No, I just said we have evidence that there's a change.
Alpha is 5%.
Alpha is 5%, so what does that mean?
There's still a small chance that there could be a change, it's just we have evidence that it's most likely going to happen when it is 4.089.
Alright, so this is the only thing that's possible. Okay, so let's say gas prices have actually, the gas prices are just frozen, okay? Nobody's allowed to change their gas prices or something. What's possible, okay, is that last week, when I randomly select 30 gas stations, I, by random chance, happened to pick gas stations that were low in price. This week, when I chose 25 random gas stations, by random chance, I happened to pick 25 that were higher in price, okay? My p-value is 0.01, which means the probability of observing my data or something more extreme, if the null hypothesis were actually true, is only 1%. But there's a 1% chance that it happened just because of my random sampling. Okay. So what this is saying is that if this is what my data shows, then yes, it is possible that gas prices didn't actually change, and that I happen to just draw the 1 in 100 sample that has led me to the conclusion that it has changed gas prices. Is that okay? Because I'm picking the gas stations at random. What's possible is that the ones I picked last week and the ones I picked this week have given me the illusion that it has changed. And even the math checks out. We do the statistics and maybe the math checks out, and the math says, yeah, it looks like it changed. But that's just because the samples that I got just happen to be kind of that weird scenario where it looks like it has actually changed, but in reality, it hasn't. Okay? So that would be a mistake, because here we've concluded that there is a change in gas prices, but that could just be because my random sample happened to lead me to this conclusion. Okay. So maybe we made the right decision, okay? But it's possible, possibly wrong. Okay? And it could be wrong if the samples that I selected just happen to be weird enough to lead me to the wrong conclusion. And so that's what we've got going on. Conclusion, if it were wrong, this would be known as a type 1 error. Okay? There's two kinds of errors. There's a type 1 and a type 2. We weren't very creative with the naming. Okay? But we use Roman numerals. So it's a type I, type 1. Roman numeral 1 error. The other conclusion that we can make, so let's say we go and we change up our numbers and stuff. Let's say we have a similar problem, but let's say we're comparing between a month ago and now, okay? So we're looking at 1 month ago versus now. Okay, we're still dealing with gas stations. This is still kind of this thing that we've got going on. Okay, in this situation, let's say our p-value happened to be large. Let's say our p-value is equal to 0.09. Okay, and we're using alpha equal to 0.05. So in this case, my p-value is greater than 5%. And if my p-value is greater than 5%, what is the conclusion that I make?
Don't reject the null.
We do not reject the null hypothesis. Okay? And then we would say, we do not have evidence that gas prices changed.
Did you just guess at the p-value?
Yeah, I'm just making up numbers, okay? I'm just making up numbers. I mean, we could work through the whole problem and get this, but I'm just jumping to the conclusion because this is where it's most relevant. Okay. So our conclusion here is that we did not reject the null. Okay? This could also be possibly wrong. Possibly wrong in that maybe there actually is a difference. Maybe the gas prices actually did change. Average gas price might have actually changed. But our data has led us to the conclusion that they didn't change. All right, again, just by random chance. So if we made a mistake this way, this is called a type 2 error. So we have a type 1 error and a type 2 error. So what's the difference between a type 1 and a type 2 error?
Type 1 is the null is rejected, that one's isn't.
Yeah. Okay, so again, when we do a hypothesis test, there is the truth, and we're seeking the truth. What we want to know, there's either two possibilities. Either the null hypothesis is true, or that the null hypothesis is false. Okay. The truth is this or this. Okay, either the null hypothesis is true or the null hypothesis is false. When we make a decision, there's two things we can do. We either reject the null hypothesis, or what? Or we don't reject. Okay? So we'll go through this. And don't shout out the answer, just think in your head, is this a good thing or a bad thing? And if it's a bad thing, what kind of error is it? Okay. If the null hypothesis is true, and we reject the null hypothesis, is that a good thing or a bad thing? Just think. The null hypothesis is true, and we reject the null hypothesis, is that a good thing or a bad thing?
Bad.
That's a bad thing, okay? So that's an error, okay? And is that a type 1 or a type 2 error? It's a type 1 error. If the null hypothesis is true, but we have rejected it, this is a type 1 error. If the null hypothesis is false, and we reject the null hypothesis, is that a good thing or a bad thing?
Good.
That's a good thing. That's the correct decision. If the null hypothesis is true, and we did not reject the null hypothesis, is that a good thing or a bad thing? Null hypothesis is true, and we didn't reject it, that's a good thing. That's also the correct decision. And if the null hypothesis is false, and we didn't reject it, that's bad, and that is a type 2 error. Alright, the probability of a type 1 error is equal to alpha. Probability of a type 1 error is equal to alpha. This is the same alpha that we choose, usually 5%. That's the probability of a type 1 error, okay? 5% or whatever alpha you choose, that's the same alpha. That's the probability of a type 1 error. Basically, when you choose alpha equal to 5%, you're saying, I'm okay with a 5% chance of making a type 1 error, okay? Okay. With a 0.05 probability of a type 1 error. On the other hand, the probability of a type 2 error that is known as beta, okay? There's no easy easy calculation for beta. We're not going to worry about figuring out beta. But you should know that the probability of a type 2 error is beta. Okay. So the first letter of our alphabet is what? A. Or the first letter of the Greek alphabet is alpha. Okay, so type 1 is alpha. And second letter of our alphabet is B. In Greek, it's beta. So type 2 is beta. Okay, that's how we get alphabet. Alpha and beta. Oh. Alright. For real. Okay. Probability of type 2 error is beta, and that's all you need to know. Okay? We're not going to worry about the calculations for that. Is that okay? Okay. So, problem on a test might go through, and it'll have you go through, and it'll ask you, what's the conclusion you make? Okay? It'll say, what's your p-value? What's the conclusion you make? And then it might ask, if your conclusion was wrong, what kind of mistake did you make? Or what kind of error did you commit? And your answer choice will be, if my decision to reject the null hypothesis, so this would be one answer choice. If my decision to reject the null hypothesis was wrong, that would be a type
1.
Type 1 error. Or another choice would be, if my decision not to reject the null hypothesis was wrong, that would be a type 2 error. Okay? And then you'll have to decide based on your previous work. Because when you make a decision, you don't know if it was the right or wrong decision. That's yeah. So let's say somehow we found out that our decision was wrong. Okay, so we've come to the conclusion to reject the null hypothesis. If that was a mistake, is that an error, or did we do the right thing? It would be an error. It's an error, and that would be a type 1 error because I chose to. Yes. Okay, let me talk about sampling methods. Okay. All right. So this is now chapter 12. And there's just a few. I just need to define a few things, okay? Okay, so all of this whole time we've been talking about, yes?
Was what we just learned chapter 12 too?
That was what.
No, that was actually the end of hypothesis testing with chapters 8 and 9. Okay? Yeah. So this is chapter 12, and this is on sampling methods. Okay.
Oh, that was in chapter 12?
Yeah, this stuff. I'm sorry. That was just kind of a supplement to chapters 8 and 9.
Oh, okay.
Huh? It doesn't. It's stuff you need to know. Okay. All right. Sampling methods are from chapter 12. So this whole time we've been talking about how things have been randomly selected. Okay. So usually when we say when we're selecting a sample, we select a sample in the hopes or hoping that our sample is representative of the population. default method, or the one that we assume, is simple random sampling. SRS. In order to do simple random sampling, do you guys remember how we do simple random sampling?
It's always on
Simple random sampling requires that we have a list of every single person that could be selected, or every single item, or every single individual that could be selected. Okay? Requires and then we just randomly select individuals using random numbers or something. Okay, we use random numbers or some other random method. Select individuals one at a time. And that's simple random sampling. The hard part is getting this list of every single person that can be selected. So sometimes we can't do simple random sampling because we can't get that list of every single person. So we have other methods that will help us get samples, okay, that well, for different things, okay. So other possible sampling methods. Okay, one is cluster sampling. We use cluster sampling if getting the list of individuals is difficult, but getting a list of clusters is not difficult, okay? So in cluster sampling, the population is naturally divided into subgroups called clusters. So the population is made up of clusters. And then the list of everyone, the list of individuals is difficult. But list of clusters is we randomly select clusters and then once we randomly select clusters, we either survey everyone in each of those clusters, or we do random sampling within the clusters, okay? Let's put on there, okay. We either everyone in each cluster in the clusters, or do SRS within a cluster, within the selected clusters. Alright, so let me give you an example, and I hope this will make more sense. So let's say you wanted to do a survey of people who attend church, okay? So your population, let's say, is churchgoers. Alright, you guys, just settle down, whoever you guys are that's talking. I can't pinpoint where the murmuring's coming from. Just settle down there. Okay, so let's say your population is churchgoers, or churchgoers in Los Angeles County. Okay, doesn't matter. It's going to be difficult to get a list of every single person who goes to church in LA County. So simple random sampling would be really difficult to do. But it's relatively easy to get a list of all the churches in LA County. Okay, that's a lot easier to do, to get a list of all the churches, than it is to get a list of every single person who goes to church. Okay, so what we do is we get the list of all churches. That forms our clusters. Okay. Okay, the churches are clusters. We randomly select some churches. Okay, and so let's say you selected, this church and that church and the other church and whatever. Once you've selected those churches, then either survey everyone in the church or do random sampling within the church. Okay. Do random sampling in selected churches. Okay. Or select everyone in the selected churches. Okay, so that's a cluster sample. Is that okay? Alright. We'll wait for you to copy that last one. Do random sampling in the selected churches, or select everyone in the selected churches. Okay? It depends how big you need your sample. Does that make sense?
This is it?
Huh? We got 2 more sampling methods. Okay. Is that okay?
Yeah.
Yeah. And then another sampling method systematic sampling. Systematic sampling. This works best if there's a natural line or cue. And basically you just say, I'm going to select every 8th person, or every 10th person, or every nth person. Select every 10th person, or 8th person, or whatever, kth person in line. Okay, so that would work if, at, let's say, like a traffic stop, and you need to pull people aside, a random inspection or whatever. That works, okay? Or if the, I don't know, checkout, maybe every now and then your receipt will say you've been selected to take a survey. Okay. They might print that on every receipt, or they might print it on every 5th receipt, or something like that, depending on where you go. That's systematic sampling. Okay, and then and this last method is called stratified sampling. In this one, our population has subgroups called strata that are, in each strata shares kind of a, within the strata, the people all share, a common trait, okay? Okay, and within each strata, so for example, our population could be stratified into gender, male and female, and other, or into race, and into different races, and we have this race and this race and this race, different strata, where the individuals within each strata share some kind of common trait. Okay, and then basically you either know or you assume the strata makes up certain proportions in the population. So you know or assume the strata have proportions in the population. Okay, so for example, maybe you're assuming it's 0.50 male and 0.50 female. Okay, that's two strata, and you're just assuming that they make up equal parts. So then when you select your sample, you make sure that the same proportions apply to your sample. in this case, let's say you select, so the example is that select a sample of 80 people. You want to make sure that 40 are male, or half, and 40 are female. You just want to make sure that the same proportions apply to your sample as they exist in the population. Yes?
So it won't be random at all?
No, it is, you select your males at random and your females at random. But you just apply these proportions in your selection procedure. Okay? So you select people at random until you kind of meet this quota or cap. And you say, okay, I just want to make sure that we get enough of each strata. And so that's stratified sample. Alright, is that okay? So on the final exam, I'm going to describe a scenario, and I'm going to ask you to decide which type of sampling method was used. Okay, let's take a break, and then we'll finish the class.